Alright, in this video, we are going to talk about the limit of a function. Limit is a huge piece in differential calculus. So I have a function right there. Y equals to x squared minus x plus 2 is a quadratic equation, right? So the graph of a quadratic equation looks like a parabola. My question is, as x approaches to 2, what happened to the y value? So as x approaches to 2, you have to look at the left side and the right side. Speaking of the left side and right side, people get confused all the time. What is left? What is right? I don't know what you are saying. So okay, for left side and right side, let's draw a number line. So I have 2 in the middle, right? So what kind of number goes to the left hand side of 2? Anything less than 2, right? So let's say you have a 1. What number goes to the right side of 2? Anything greater than 2. So let's say you have a 3. So as x approaches to 2, I want to check the left side. This is your left hand, right? And then this is your right hand as x approaches to 2 from the left and from the right. So here is how we are going to do the work. We start at 1. Okay, we start at 1, and then we take a number that is one step closer to 2, take another step, one more step, and then we are getting closer and closer to 2 to see what happened. How do we get this y value? All you have to do is you plug in the 1 to the equation, you plug in the 1.5, you plug in the 1.8, you plug in the 1.9 to the equation, so on and so forth. You square the x value, subtract the x value, you plus 2, you put the result in there. So that is x approaches to 2 from the left. So as x approaches to 2, one step at a time from the left, what do you see in the y value? What's the pattern? Tell me. It's very easy. We have a 2, 2.75, 3.44, and then as x getting closer and closer to 2, we have this value, 3.997001. So that is actually very close to 4, right? So as x approaches to 2 from the left, y approaches to 4. Let's drop this right here. As x approaches to 2 from the left, I want you to get used to this. There is a minus in the upper right hand corner. This minus is not an exponent. It's not a negative. This minus means left side. Comma, y approaches to 4. What about the other side? As x approaches to 2 from the right, so we start at 3. 3 is right here, right? And then we want to go to 2 from the right hand side. So 3, we take a step closer to 2, closer, 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 closer. So this is very, very close. The 2.001 is like right here, 001. And then the 1.999 is there. Now, x is so close to 2. What happened to the y value? We have 4.03001. So as x approaches to 2 from the right, this plus, look at the upper right hand corner of 2. The plus is from the right. The minus is from the left. Y approaches to 4. This is how we draw the description using appropriate symbol. So we are going to put this in limit. So here is how we are going to express the language. The limit, so listen to me carefully. This is how we read the limit. The limit as x approaches to 2 of x squared minus x plus 2 is equal to 4. Why is this equal to 4? We have to check the left limit and the right limit, make sure they are both equal to 4. So first, we look at the left limit. As x approaches to 2 from the left, the minus means the left of this function. The limit of the function is equals to 4. And then on the right hand side, as x approaches to 2 from the right, we draw a plus of this function. The limit, the y value is equals to 4. So therefore, we have the left side equals to the 4, the right hand side equals to the 4. What about there is no plus or minus? No plus or minus means here. As x approaches to 2, listen, from either side. That is what no sign means. Minus is a left, plus is a right. No sign means from either side. The limit approaches to 4, or you can say the y value approaches to 4. We go back to the picture. As x approaches to 2 from the left, we got y approaches to 4. As x approaches to 2 from the right, y approaches to 4. So therefore, the limit is equals to 4. You might ask me, hey, this I don't think the limit is necessary. Look, you have x squared minus 2 plus 2. All right, I don't need to study the limit. I don't even need calculus to do this. I can just say, all right, you want x equals to 2, right? Fine, I do the work for you. So 2 squared minus 2 plus 2. So that is 4 minus 2 plus 2. That is equals to 4. The job is done. Why do we still need the limit? Right? So you can do this without limit. But the thing is, let me tell you, plug-in is not always work. You can't just write a limit and then plug in the x value to get what the limit equals to. That works once a while. That is not going to work every single time. So let me give you an example. What happens if the direct plug-in, you take the x, you plug it in, just like what you said, I don't need calculus, all I need to know is some basic algebra, I can solve the limit, right? So let me prove you wrong. Now, the direct plug-in works in the previous function, but not in this one. Look, how about this? We have a limit as x approaches to 1 of x minus 1 divided by x squared minus 1. You can plug in, right? So if you plug in 1 minus 1, 1 squared minus 1, you have 0 divided by 0. Punch this to your calculator. What is that equal to? This is undefined. We are not able to do this. Let's take a look at the graph of this rational function. So this one, x squared minus 1, right? X squared minus 1. X cannot be equal to what? X cannot be equal to 1, right? So this x, when x is equals to 1, we have a trouble because we have a 0 in the denominator. So if you look at the graph, we can see that when x is equals to 1, there is an open circle, right? This is the curve. There is an open circle when x is equals to 1. So if we zoom in, there is an open circle when x is equals to 1. But if you are very sharp with your algebra, you might say, all right, okay, x cannot be equal to 1, I get it, then there is a vertical asymptote then. But the question is, I don't see the vertical asymptote. I do not see any vertical asymptote. I see that you punch a hole right there. How come there is no vertical asymptote? X cannot be equal to 1, right? Let me show you why. So in this problem, the direct plug-in is not working. So what you have to do is, you have to do some algebra. So we start with limit as x approaches to 1. And then this, we want to simplify. It's not really simplify. We want to factor the denominator. X minus 1, x plus 1, and then you get rid of the x minus 1, right? So that equals to limit as x approaches to 1. We have 1 divided by x plus 1. So now we are able to plug in x. As x approaches to 1, we have 1 divided by 1 plus 1 equals to 1/2. So that is equals to 1/2, which is equals to 0.5. And you just said that x cannot be equal to 1, but after we did some algebra, x can be equal to 1 now. Okay, x can be equal to 1. You look at the function. There is an open circle. What is open circle, by the way? What is an open circle? Open circle is not 0, it's an open circle. Open circle is like you are driving, okay? You are in your car, you want to drive from point A to point B, okay? From point A to point B. Open circle is, I am going to punch a hole right in the middle, okay? Right here. I am going to punch a hole. Can you still go from point A to point B but just driving on this road? The answer is no. You are not able to drive from point A to point B anymore because I punch a hole right there. Car doesn't fly. You will be dead. By the end, you reach to the hole. You reach to the open circle because I punch a hole in there. You are not able to go from point A to point B anymore. Same idea in here. We have x minus 1. So it looks like if you look at the factor, this x minus 1 is the biggest enemy, right? I don't want to move this picture around. This x minus 1 is the biggest enemy. It's our biggest enemy because once I plug in 1, everything is not working due to the x minus 1. However, we are able to do the algebra to remove the x minus 1. Therefore, there is an open circle in here. What if we are unable to remove the x minus 1? then when you look at the graph, the x equals to 1 will be a vertical asymptote if you are unable to get rid of the x minus 1. If you can do the algebra to get rid of the x minus 1, then the x minus 1 is an open circle. But still, at x equals to 1, there is an open circle. That means, and when x is equals to 1, the function is undefined. Yes, you're right. When x is equals to 1, you plug in a 1 to the function, this function. The function is undefined. That is absolutely right. But the limit exists. I am not saying x equals to 1 exactly. What I really want to know is x approaches to 1. That is what the limit for. We are doing limit. I am not asking x equals to 1. What I am asking is as x approach to 1. From the left side, from the right side, I am asking for approach. As x approaches to 1 from either side, we can see that y approaches to 0.5. So that's why the answer is equal to 0.5. So that is the basic concept of evaluating a limit. So in the next video, I will show you how one-sided limit works. So I will see you there.